Good morning, everybody. Thanks for coming. I see they thought this talk was going to be a lot more popular than it apparently is, so I guess there's plenty of room down here. If you guys want to heckle me at the back, you can come closer. Some of the text might be quite small, so if you have problems reading it, just shout out. So who am I? My name is David Litchfield. I've been around the block a few times. I have a whole bunch of CV IDs to my name, and many which don't actually have CV IDs. 7 cert advisories based upon my research. I don't know whether that's a good thing or a bad thing. And a fair number of white papers. Written a couple of books, although the last one was in 2007, so I better start updating sometime soon. I worked on a number of projects like NGS Squirrel. If anyone, I guess if you're in this room, you're interested in database security, so there's a very small chance you actually may have heard of a tool called NGS Squirrel. But I then set up a few companies and eventually retired, or semi-retired. I went diving with great white sharks, as you'll see in a minute. If you're interested in this kind of database talk, which I presume you are since you're here, you can follow me on Twitter at dlitchfield, or if you want a direct conversation, david@davidlitchfield.com. I said I was a shark diver. This is one of my pictures. This is what I do in my spare time when I'm not raising my kids. So let's talk about Ebusiness Suite. Can I get a show of hands in the room to see how many people actually have Ebusiness Suite on their network? Quite a few. Okay. Is anybody running 11.5 still and going through an upgrade process? Okay, so a lot of this, I'll be talking about 11.5 and 12.2 and versions in between. Some of it, if you're not running 11.5, I guess, you know, some of this talk is irrelevant, but I guess the principles still apply. So Ebusiness Suite, as apparently many of this in this room know, is a very large product. It's got a massive attack surface. And as someone responsible for the security of an Ebusiness Suite server, that's actually slightly worrying. So this talk basically will be looking at that attack surface, how one can assess it and try and reduce it, and make your security posture a lot better than it currently is. So the essence of this talk is based upon some consulting engagements with some customers. So this isn't just like, you know, oh, go ahead and drop this kind of thing and you'll be fine. Because obviously we know if we're running Ebusiness Suite, a lot of critical, you know, probably money and HR info and all that good stuff is going through it. And if we break that application, then it's going to be somewhat problematic. So these methods have been tried and tested on a couple of customers at least. So take the principles away with you and see if you can apply it to your environment. Okay, we know it's got a big attack surface, but apparently it's okay though, because if you look at the secure configuration guide for Oracle Ebusiness Suite 11.i, on page 42 it says, of the many potential SQL injection flaws we have seen reported, not one has been a confirmed example. So that to me says, well, it's like a red flag to a bull essentially. It's like, well, hold on, wait a minute. I know of many instances where people have previously reported SQL injection flaws to Oracle. So why are they saying this? I mean, is this post-fact or is this something that they delivered out the box? So I wanted to take a look at the most patched, the most up-to-date version with the most up-to-date patches on it to see if SQL injection flaws did actually exist in this product still. It being 2016, one would hope not. So I started this in November, basically, and obviously skipping ahead in the slides, talking about the attack surface, 15,000 JSPs in the web root. So that's a lot of attack surface. If you are running Ebusiness Suite 11i, there's a PL SQL gateway, which is now thankfully gone in release 12. It itself was a very rich source of vulnerability. There's forms, there's servlets, and then there's the database server behind that and the concurrent processing server behind and so on. So there's a lot of juicy stuff which an attacker can look at in terms of trying to find a way to break into your system. So I started an in-depth review in November 2015, looking at 11.5 first and then moving on to 12.2. After 1 week of effort, I'd found and reported a large number of issues to Oracle, including SQL injection flaw that we had been told in the secure configuration guide didn't actually exist on the system, and were all false positives. So 21 SQL injection flaws, 26 cross-site scripting, 1 open redirect, 2 DOS, and the DOSes were really simple things, like a loop counter that basically didn't say, put an upper limit on what the loop could go to. So you just specify 1 to 1 billion, and that causes the database server to sit there and go in an eternal loop. Well, not an eternal because it stops at 1 billion, of course, but you get the idea. Most of the flaws were in the PL SQL gateway and the JSPs, and I did another week's worth of effort on 12.2, and we had a similar number of issues. So it wasn't good, considering this is a product, an aged product, has been around since, well, at least 2000. In fact, some of the code, when you look at it, is actually developed in 2001, which is, strange that code hasn't been fixed in all that time. We are told, obviously, by Oracle that they have a robust security assurance program to ensure that when they ship these products, these kind of flaws don't exist. So one needs to question why these flaws do exist and whether their program is as robust as they think it is. I'll quickly run through some 11.5 issues. So what's interesting is there are 3 Apache aliases that point to the same physical directory on the file system. So if you look at OA_HTML, all the protection that is afforded by Apache is essentially been applied to that directory. But there's an HTML directory and a JInitiate directory. So things like the appsweb.cfg file, which contains usernames and passwords, connect strings, and so on, we can get direct access to basically by just specifying /HTML/bin and so on. Often you'll find that there's an SQL net.log file as well, which dumps a wonderful source of information about what's going on internally in the network. And there's, ironically, one of the Apache configuration files is called trusted.conf. Do not trust trusted.conf. Essentially, it uses a bunch of location directives that haven't been sufficiently written sufficiently well enough to actually protect against things. So, for example, DMS0, it basically gives you some information about what's going on in the server and things like memory allocations and so on. You are denied access to it if you attempt to access it because of this location directive, or to deny, allow, and deny from all. However, if we just put another / in front of DMS0, we can bypass that location directive. And there's a whole bunch of them in this trusted.conf that we're not supposed to have access to, but we can gain access just by inserting another / in front. That's, doesn't give us remote code execution or anything interesting. However, again, on 11.5, there is the PL SQL gateway. Now, the PL SQL gateway essentially is a part of the web server. It's an Apache module that basically takes a request from the web client, i.e. the browser, and essentially proxies it to the database server. So the client will say, execute this package and procedure, and the web server will turn around to the database server and say, execute this package and procedure as requested by the client, return me the results, and I'll pass it back down the HTTPS chain. Now, that's obviously a risk. So Oracle have decided that they would limit the exposure by specifying what PL SQL packages and procedures could be accessed by listing them in a table. So there's a table called fnd_enable PLSQL. There's about 700 packages and procedures in that list. I looked at a sample of 40 of them, and 12 had SQL injection in them. So I didn't bother looking at the whole 700 because, as I said, sampling it gives me an idea on how robust that code is, and we don't need to look any further to say Oracle or request of Oracle that they do actually do a code review on their stuff before shipping the product. So we'll look at a couple of examples of exploiting these. Now, what's interesting is these are unauthenticated. So if someone has access to your network, for whether they're an internal employee or someone has, compromised a client on your network through a phishing attack or whatever it happens to be, and they have direct access to the Ebusiness Suite web server, without username and password, they can execute these kind of attacks. Now, what happens is the PL/SQL gateway connects to the database server as the apps user. The apps user has almost as many privileges as sys, essentially. It's a very highly privileged account. So anything that any arbitrary SQL that an attacker might supply in a SQL injection attack will execute as the apps user. And apps has obviously access to all the data that you're trying to protect access to. So we'll look at a couple of them. So one of the packages, hrutil disp_web, has a procedure called dexl, basically, and it takes in a URL as a parameter, or it's not essentially it's called p_URL, but it turns out it's not a URL. And what happens is it decrypts that p_URL using the icx_call.decrypt2 function and executes it using the execute dynamic SQL procedure. So if we look at what icx_call.decrypt2 does, it basically takes a text column for a supplied text ID, and whatever it finds in there, it will then go and execute it back here. So once decrypted, have I got a, yeah, I do. This begin and end basically is called an anonymous PL/SQL block. So whatever this decrypts to, it will go ahead and execute that for us. Now, the question is, how does one get stuff in this apps.icx_text table? If we can do that as an external attacker, we can basically get it to execute arbitrary SQL. So, of course, we review the source code of the PL/SQL package, and we look at a procedure called display fatal errors. What's of interest here, if you see here, it takes a parameter p_message from here, and then encrypts it using icx_call.encrypt2. It's not actually encrypted. Basically, it takes whatever it is, puts it in this table, and gives it an ID. Once we have that ID, once we've managed to insert into this table, because that's what the encrypt2 code does, it basically inserts into the table the text, and gives you an ID back. Once we've done that, we can then execute arbitrary SQL. So all we do here is there's a package called dbms_aw, and one of the functions on that is interp. And there's also an interp silent. And we can execute arbitrary OLAP DML commands. And one of those commands, fortunately for us as an attacker, is sleep. So we can get the application to sleep for 10 seconds, rather than getting. For a lot of Oracle applications, basically, people will try and loop, the DBMS obfuscation toolkit and encrypt something 10,000 times to get the application to hang for 10 seconds. But this is much more simple than that. We just, cause it to sleep using this DBMS AW on top. So that's the arbitrary SQL we're doing. It's really benign, doesn't do anything. It just causes the app to hang for 10 seconds. Once we enter that URL, we are directed to this URL here, and we get this p_message, and that ID essentially is the ID returned for the text that's been inserted into the icx_text table now, nicely for us. So we then go back to the dexl procedure and supply that ID at the end, and what happens is when the dexl procedure executes, it calls that icx_call.decrypt2 with that ID, takes the text out for us, embeds it in that anonymous PL/SQL block, and then executes it for us. So we've now executed arbitrary SQL as the app's user. Another interesting one, the Oracle SSWA package has a procedure called execute. Of course, when you're doing this kind of research, you basically home in on things. A nice little grep, for certain phrases will highlight where potential areas of interest are. And of course, this execute stands out like a sore thumb, so a bit of investigation. We find that it takes a parameter called E. E is decrypted using icx_call.decrypt, which is slightly different. It actually is encrypted this time. And so if we look at this pre-encrypted parameter, it decrypts to this number here, basically. Now that 2633 is passed to a function called run function. And what that does, it looks up the web HTML call table for that function and extracts the function name and executes it. So in this case, 2633 is icx_change language show_languages. Now, if we review the code further, if the parameter p exists, that too is decrypted and concatenated. So what happens is, if we encrypt using the code for the encrypt function, we basically all we need is access to our own copy of Ebusiness Suite that has the ICX_call.encrypt function, and it spits out a fixed field for us. If we encrypt bracket semicolon http.p bracket user, essentially what we're going to do is get the username of the account that our SQL is executing as printed back to the screen. So what will happen when it is eventually executed, P is decrypted and it's concatenated to the procedure that relates to 263, which is show languages in this case. Our P parameter is concatenated after decryption. This stuff basically is our little hack to get it to execute, and it executes as we can see down the bottom. If you view the source of the HTML that's returned, that's our http.p user, and it's showing that it's apps. So here are some CV IDs from that little bit of research in November related to this assessment of Ebusiness Suite. So there's quite a few. That list is for the stuff that was patched in January, I think. So it's not comprehensive. We'll get to more CV IDs in a minute. I think this a copy of this paper, these slides. You'll have a copy of these slides somewhere. So let's look at, how are we doing for time? 12.x issues. So again, spent 80 hours doing an assessment. There's a couple of Java deserialization flaws, so simple remote code execution. SQL injection, there were 8 SQL injection flaws. In fact, I should have updated the slide. I found more in the interim. A whole bunch of cross-site scripting. I seriously lost count, there's so many. A bunch of cookie exposures, SSRF. Directory traversal, denial of service, and XXE. In fact, one of the XXE vulnerabilities that turned out, one of the areas where I thought there might be an XXE vulnerability, and it turns out there wasn't. It's basically looking for things like system and public, and basically causes an exception if you try to do an external entity attack, XML entity attack. And it did have a cross-site scripting flaw in it. This is in the B&E application service. Again, I think there's a paper in, I don't know whether they print books these days or whether it's on a slide, on a disk or not. But essentially, there was a cross-site scripting flaw in this B&E application service, and but it was a trivial to spot kind of thing, and it was caught by the anti-XSS filters in Chrome and Internet Explorer and so on. So I thought about it for a minute, and I was thinking, well, okay, we can't use external entities, XML entities, but what happens if we used internal XML entities to encode our attack to bypass the XSS filters? So there was a nice little neat attack, because obviously on the back end, it's being processed by the XML processor, and your XML attack, your XSS attack is no longer straight, alert 1. That's invisible to Chrome and IE on the way out, but when it is processed on the back end and everything is put back in place, it executes our XSS now. So there's, as I said, I think it's on the disk. There's a little paper on exploiting internal entities, XML entities, to bypass the Chrome XSS and IE filter. If we have time, I've got the paper on the laptop, so I can quickly show it to you. A lot of this stuff was actually patched in the most recent July critical patch update, which is great, but some of the stuff we're still waiting patches for. So I want to talk about one of the SQL injection flaws in the JSP things, and it's really important to note that there are multiple ways to skin a cat. I hate that as an expression, and it's quite ironic, actually, that there are not multiple synonyms for this expression when you would think there'd be lots of synonyms for it. So this SQL injection flaw, it's a very simple one to exploit. The JSP is called BIS akargn.jsp, and essentially you do it's one of the parameters p search by, and a simple single quote will break you out of it. A typical, standard SQL injection flaw. And again, it executes as sys and so on. We can access that directly, which, the URL is oae_html. We'll just call it bis.jsp, just for the sake of ease. Now, if you, as a defender, think, well, we're not actually using, the bis.jsp file, so why don't we either create a mod rewrite or a location directive to deny access direct, to this bis file? Then that's a great step forward, obviously. But there are multiple ways to access this, and that's one of the problems with trying to defend against attacks in Ebusiness Suite. So as an example of this, there's a file called rf.jsp. The rf stands for run function, basically. And what rf.jsp does, it takes an ID, essentially, and looks up in a table the name of the web call to make. And in this case, there is a web call to this bis.jsp file. So all we need to do is get the ID from this table, which happens to be 11091 in this case, supply the p search by parameter, and what rf.jsp does, it basically executes that internally to rf.jsp, passes it the p search by parameter, and again we now have access, direct access or indirect access to this bis.jsp page, despite the fact that we might have blocked it using a location or a mod rewrite directive. But it gets slightly worse because there's other methods we can do it. Commonly used in Ebusiness Suite in the JSPs are JSP forwards. And essentially what that does, if given the name of a JSP page, it will forward any parameters and so on to that JSP that is being included, essentially. It's like an include, but it's a forward. Now, there are a whole bunch of JSP pages that take a user supply parameter as the file to which to forward to. So again, if we have found that as an attacker, someone has denied direct access to the bis.jsp file to us, we could use one of these forward attacks. And there's a whole bunch of ways of doing it. So as you can see, we essentially pass the name of our JSP page as a parameter, QOT FRM main file, and we supply our p search by arbitrary SQL and so on. And these are all different files, different ways of doing it. And here's another one. Now, what's ironic is in 11.5, which is an older and more vulnerable version, the only kind of file you can actually forward to and include in this way is a JSP file or an HTML file. However, in 12, we can access things like XML files, which might contain usernames and passwords, CFG files, log files, and so on. So in 12.x, we can actually access non-JSP or non-HTML content as well and leak information that may be useful to us further on down the line. So something, again, to be careful of. So again, we're still looking at multiple ways to skin a cat, how to access this one single flaw. There's multiple ways of doing it. So there are lots of SQL injection flaws. I think I've made that point quite clear. So now we are at that stage where we are executing SQL in the database, arbitrary SQL in the database as the app's user. So we'll look at how one, in fact, increases their privileges, improves their privilege situation from the database. So with web-based applications, and Oracle does not batch SQL statements. Like in Microsoft SQL Server, you can say, select from this table, delete from that table, do this, do that, and shut down the database, all in one batched SQL query, essentially. Oracle does not do that. It will just execute one SQL statement. So we have to trick it into executing arbitrary SQL statements for us and chaining them together. So we use what's known as an auxiliary inject function to do that. So if you look through the code on an Ebusiness Suite server, there's a whole bunch of auxiliary inject functions, or functions that we can essentially used to our nefarious purposes. So what we're looking for, basically, is a function that takes in parameters only, doesn't have a Boolean as an in parameter, and doesn't return a bool, and has to return a varchar or a number or something like that, and takes an arbitrary SQL statement and executes it for you. So here's a couple of examples. So the ASG custom pvt.exec cmd function will take a parameter and execute it for you. So if we look here, the arbitrary SQL we're supplying, it's an anonymous PL SQL block, begin DBMS output, put line, user, end, basically. So this function will execute that for us. So as an attacker, we can simply turn around and say, if we inject, first off, into our web-based SQL injection floor, and we're wanting to execute arbitrary SQL, we can essentially declare a pragma autonomous transaction. That basically says to the Oracle database server, what we're executing here is a discrete little unit of code execution in and of itself, so don't worry about things like that. You're allowed to commit transactions in this anonymous PL SQL block and add users or grant DBA privileges or whatever it happens to be, providing the privileges are there. So we essentially supply our arbitrary SQL and, in effect, batch arbitrary SQL. So there's a whole bunch of them. WIP underscore mass load utilities dynamic SQL. Again, it takes an arbitrary SQL statement, and we have to supply a couple of bind variables in this case. MSC get name, execute SQL, get count. There's a couple that don't exist in release 12. So if you're on 11i and the others aren't available to you, these might be of use. There are also a couple which execute a save point, and that save point basically is the beginning of a transaction. And if you are in the middle of a select statement, you cannot obviously commit a transaction in the middle of a select statement, so we can't use these in this OKC underscore WF.exec and so on. We can't actually use those in a select-based SQL injection floor. But if you're injecting into an insert or a delete or an update, it's perfectly valid to use these things because we're obviously in the middle of a transaction already anyway. So there's a whole bunch of ways we can get from apps to sys. One might ask the question, why does one need to execute code as sys when you're already executing as apps, and the apps has high privileges and the apps has all the access to the data we're interested in anyway? And the reason is because you might want to do things that apps can't do. You might want to access the file system in an arbitrary way, execute arbitrary OS commands, for example, that might require sys privileges. So we have to look at ways of how one can execute SQL as sys from apps. Now, there's a whole number of ways we can do this. One is direct execution of sys-owned packages and procedures that might be vulnerable to SQL injection. So this is direct execution, or we can do indirect execution. What we mean by that is if there's a PL SQL package or procedure that is owned by system that might be vulnerable to SQL injection, then we can execute arbitrary code as a system, and whatever system can do at that moment in time, we can then gain extra privileges. So for example, system can execute dbms underscore sys underscore SQL, and we'll get to that in a minute. But the point is we can chain our attack together. So up until very recently, the patch just came out for it, and I reported it in October 2014, so it's taken 2 years to get to this point. Apps could execute dbms underscore sys underscore SQL. Now, this package is owned by sys, and it allows you to specify the user ID of the account under which you wish to execute SQL. So if you specify 0, which is the user ID for sys, then you can, provided you have access to this dbms underscore sys underscore SQL package, you can execute arbitrary SQL as the sys user by, as I said, specifying user ID 0. Now apps, the reason apps had access to that is because the fnd underscore websec package essentially alters a database user's password. So, and it does that via a call to dbms underscore sys underscore SQL, passes user, and it passes it as the sys user. But it strikes me as rather odd when we could grant the apps user the auto user privilege directly, so we can then do an execute auto user statement, as opposed to granting apps the ability to execute arbitrary SQL, whatever it wants to do as the sys user. So they tightened up privileges that way. It's a not employing the principle of least privilege kind of flaw. Not earth-shattering, but useful in some attack scenarios. But Oracle, when they patched this, introduced a new procedure that was owned by sys, executable by apps, and using definer rights, and is vulnerable to SQL injection. So their patch actually leaves us in the same predicament. We can still execute code as sys from apps. And we'll look at that in a second. So in terms of a direct execution of what an attack would look like. So what we're doing basically is we're opening a cursor called C. We're then parsing as the user ID, sys user ID, which is 0. And the code we're executing is the current user, display the environment and print it out to the screen. And if we see that, we're connected as apps, but when that code executes, it executes as sys. So webifying that attack, essentially, we use our auxiliary inject function, in this case, apps.psbws ACCTL1.dsql execute. Here's our declare pragma autonomous transaction. This is us opening the cursor, parsing the SQL, and again, all we're doing is printing current user to the screen. We could, if we wanted to, do something like grant DBA to public, whatever your attack needs to be. The point is it's executing there as user 0, which is sys. We then execute it, close the cursor, because that's what good hackers do. They clean up half for themselves and not leave memory leaks, and then end. That we can inject into a web-based JSP vulnerability, SQL injection vulnerability, and that will then execute as sys for us from apps. But remember, that's now been patched, so there is no longer direct execution of dbms_sys_SQL as the apps user. However, system recall does have the ability to execute dbms_sys_SQL. So what we can do is now find a vulnerability in a system-owned package or procedure, which of course there is one. System.adapps_private basically is vulnerable to SQL injection. And what we're going to do is build our attack and layer it together. So what we're doing here is we are injecting into our auxiliary inject function, which in this case is apps.asg custom pvt exec cmd. We are exploiting the SQL injection flaw in adapps private doapps DDL. We're printing the user 1, we need a bind variable there, and we're doing an execute immediate internally to that, declare pragma autonomous transaction. Here's our parsing as user 0 down here. And so what will happen is this executes as apps, this executes as system. System has access to dbms_SQL, which it then executes for us. So we've layered our attack in one single thing. Now in the real world, webifying this, we remove obviously the select and the from dual, put a double pipe operator in front of that and at the end of that and our single quotes, and then double up all instances of quotes here. So that one would become 2, that one would become 4. This 16 would become 32. The reason why I didn't webify it before is because having 32 here and here and here, it just looks really silly. But I think that 16 is the most I've ever had to do in a single attack. Sometimes you lose track and, or one's missing, you're like, oh, what's gone wrong, But yeah, so it's an interesting attack. So again, we can pipe this without a username and password into one of the known SQL injection flaws in Ebusiness Suite and suddenly execute SQL as sys on the Ebusiness Suite server. So we've got, how much time do we have left? 10 minutes, right. So there are, as I said, 15,000 JSPs in a typical install in Ebusiness Suite. What you'll find more often than not is you're not using 15,000, you're using around about 200, sometimes more, sometimes less. So what we can do, we obviously want to strip those. Actually, I want to go back a bit. Remember, there are multiple ways to access arbitrary JSP pages via extant functionality within eBusiness Suite. You know, we can use rf.jsp, we can use JSP forwards, and so on. So it's not a simple enough case to just say, let's deny access to all the files except the ones we want to give access to. It's a lot safer to delete them from the file system or move them to a directory outside the web root. Because the forwards only work in the web root anyway. My personal preference is delete them entirely. All those files you're not using, delete them entirely, because there might be some kind of directory traversal flaw, and you can still gain access to them. So this is based upon the knowledge that there are multiple ways to execute or gain access to a SQL injection flaw. What we do is review the access logs for legitimate access, look for accesses to rf.jsp, because obviously it's an actual part of, in fact, a very popular part of eBusiness functionality, and often you'll find that developers will use rf.jsp to give access to some of these other JSPs. So just because a JSP is not listed in the access log, it might be accessed through rf.jsp. So what you need to do is extract the function ID from all calls to rf.jsp, and then look up in the FND form functions table if it's a JSP page, and then include that in the list in your whitelist essentially. You also need to look at things like included JSPs. So one JSP, A.jsp might include, you know, a JSP B, and that B might include C. So you have to do an analysis downwards as well, and also look for forwards. So a recent engagement, we went from 15,000 JSPs to just under 200, which shows a 99.99% reduction in attack surface, essentially. Admittedly, some of the flaws, some of the 200 JSPs that were left over still were vulnerable to SQL injection, but we addressed that by essentially, you know, securing ourselves. So that's the thing. Once you've done this, removed all the JSPs you don't need access to, do a deep dive code review of these things and look for vulnerabilities yourself. And if it's found, you know, to be wanting, then take steps to remediate the risk, or use mod security or something in front to improve, or improve, the security robustness, or some WAF or something. If you look at the default servlets on eBusiness Suite, there's about 80. We actually use 2 of them, so again, we just stripped them out, and we're now down to 2, a 97% reduction in attack surface. Specifically to securing 11.5, I know there's only about 3 people in the room that this is relevant to, so apologies in advance. Go through the FND-enabled PL/SQL and set enable to N for as many as you possibly can. There's about 700 that might be enabled by default. We got our list down to, it says 6, but it was actually 16. I'm missing a 1 there, I apologize. Again, it's a 99% reduction in attack surface. And remember, the review I did, there was, I only looked at 40 of them, and 15 were vulnerable to SQL injection. So that means that there's a good chance that the remaining, 600 plus packages might be vulnerable too. So it's definitely worthwhile to take the time to reduce the list of those PL/SQL packages and procedures that are enabled, and reduce it to those which the business requires access to. So that's essentially the approach, is strip it down and review what's left. Use mod rewrite or mod security to deny access to those things that you can't actually remove for whatever reason. And what's been really useful actually in the case of the previous engagements is create a custom 404 page. So if someone is actually denied access to this, do a mod rewrite and redirect them to an essentially a page that explains the page you're looking for has been removed for security reasons. Here's an ID, raise a call with the help desk, and what we can do is look at that and see if you have a legitimate business need for access to it, and then we can put it back on the web server for you. So, any questions? Sure, there's a question here.
Is that a way we can disable
Well, some of them have built-in things like cross-site scripting detection, like the B&E application actually has its own useless one. But you can't turn it off because it's built into the code, unfortunately. I mean, things like on the web browser side, you can obviously handle that by disabling things like XSS Auditor and so on. But on the web server side, no, there's typically not. In some of the WebLogic stuff, there is a filter in there that's enabled by default. You could strip that out, but my advice is not to do that because you're going to expose the system to more attacks, basically. I know you would re-enable it after the pen test, but why have that window of opportunity, you know? But yeah, there's certain profile settings that you could probably weaken as well in Ebusiness Suite, but again, it's not my recommendation to do so, because what you're actually doing is you should be assessing it under the current environment anyway. Exactly, yeah. But there are certain things you can do, but sometimes it's built into the code itself and you're stuck with that, basically. No other questions? Sure. Yeah, and there's about 5 white papers with it as well. It's not online, but I think, Chris, do you know if they're a disk or there is a disk? It's the slide should be on the disk and a couple of white papers and stuff as well. Sure, there was a question over there. Sorry, could you speak up, sir?
How long have you, like, I would like to understand, like, thank you for the presentation, but can you share a bit, like, how did you find these possibilities?
Oh, yeah, no problems, grep. For the JSP ones, simply grep and manual source code review. So some of the flaws, let me get it up because it's actually, so for a company that apparently has a robust security assurance program, so some of them are really easy to find. Let me, where's search? Here we go. SQL query. Okay, so there's a file called JTF CSV render task.jsp. It takes a parameter called SQL query. Anybody want to hazard a guess what that actually does? Right, so for a company with a robust security assurance program, how the hell did that get into production? And what's more, not be found for 10 years. That's how long it's been there for, you know? Other ones, look for query, look for table, and I said grep, you know? Look for table, look for search, those kind of things. And it gives you something, you know, to look at, do a code review, see that, you know, they're not, you know, parameterizing queries or, you know, stripping quotes or whatever it happens to be. And so, yeah, I'm not using any special tool, a command line grep and my brain, essentially. So for, as I said, for a company that has a robust security assurance program, it's slightly concerning. Any other questions? Sure.
Are there methods to locking down apps access even from DBAs? I know it's required for certain administrative tools, but you know, depending on how your team is structured, you might have contract workers that have apps passwords that have full access.
Yeah, it's that's the subject of a whole other 7 talks, basically. It's a really difficult proposition to solve. And there are ways you can do it. And, you know, you have to write your own procedures and so on. But it is hard. But if you have an environment where that kind of situation is important not to be vulnerable to, you know, all the apps, you know, and all the developers having access to the app's username and password. For a start, they shouldn't have access to the production, you know, system. They should have access to their dev stuff and they can test their code and everything like that. And the dev environment should obviously have a different password for the app's user. That's, you know, security 101. But in terms of putting a layer in front of them, yeah, it's a whole other talk. Send me an email or something, and we can talk about it later on. Any other questions? Sure, there's a question at the back there. Yeah, well, as I said, the best thing to do is spend some time reducing the attack surface. Look at what the business requires access to, strip everything else out, and then do a review on the bit that's left, basically.
That still depends on the user community installing a vulnerable version of Java. The Oracle app is requesting a requirement that my user community have a vulnerable version of Java on it. You can get around that.
So you mean on the client side, have a vulnerable version of, right. Yeah, it might require, the best thing to do, if there's a specific situation that you have, raise an SR with Oracle and get them to address it. It's probably the quickest way. My way would be a cheap hack that probably wouldn't be supported. So yeah, the best thing I can do is, first off, strip everything down. Those bits that actually are introduced in this situation in your network where you require old versions of Java on the client, raise an SR with Oracle and say you need to. The problem is because it's no longer supported. You have Premier support with your eBusiness suite for 11.x version. They might still fix it for you then, but because it is no longer in sustaining support as of December the 31st, 2015, they might turn around and say, no, we're not touching this with the barge pole, and they'll say upgrade to the next version. I'm sorry I can't be much more help than that, but it's honestly the best approach. Sorry. Any other questions? Sure.
Have you seen any methods of securing host-based current programs? So I know with EBS, there's a lot of bank transfers, wires,
Yeah.
and mostly those are noticed in shell.
Yep. So that's the one area still on my list to do. And the reason I've left it till last is because it's awful, to put it bluntly, in all versions. It's running under very highly privileged code. Often there's ways, as you said, a lot of it's shell, bash scripts and stuff, and it's vulnerable to a whole bunch of, execute arbitrary command kind of situations. So, yeah, what the focus of this talk has been, again, is securing the web front end, because once you're on that back end side of things, it's a utopia, No more questions? Then I would like to take this. Oh, was there a question there? Sure. Well, next year I'll talk about Agile, and there'll be enough. I'm joking. There's, in fact, one of my colleagues at where I work essentially has done a recent job on Agile, and Oracle have just fixed a whole bunch of bugs in Agile. In the July 2016 CPU, they've just fixed about 20 issues in Agile. So if you look at their, what was it, 280 bugs across all the products was the last CPU. That was a record for Oracle. 286 bugs. So things like Agile, Fusion, eBusiness Suite, Enterprise Manager, they're all full of bugs, massive attack surface. But the good thing is Oracle are working with security researchers and are fixing this stuff. They're getting quicker at fixing it as well. Sometimes you can report something and they'll take 3 years to fix it. There was a race condition in the workspace schema in the LT application, copy for update. And I reported that in November 2013, and they only recently just patched it, So sometimes it takes a long time to fix stuff, but most of this eBusiness Suite stuff, they've really nailed, they've got it patched out. Of everything I've reported to them in this area, I think there's about maybe 10% left remaining to be patched. So they've done a good job, Right, we'll call it time there. And thank you very much, everybody, for coming. I hope it has been useful. And